Okay, let us look at another question, and we are going to apply the work energy theorem, which states that the net work, remember I explained the net work in my other video, is equal to the change in kinetic energy. There is no need deriving this formula. You can always look up the derivation from the textbook. So now, what does this simply mean? It means that the net work is equal to KE final minus KE initial, where KE final is the final kinetic energy and KE initial is the initial kinetic energy or kinetic energy. So now let us imagine a box at rest. So you can see that initially the box is at rest and there is no kinetic energy. Okay, since the ball is at rest, there is no kinetic energy there is no kinetic energy, because kinetic energy is actually the energy due to the motion of a particle or an object. Okay, so when the object was at rest, there was no kinetic energy. Now that we've moved the box a distance or a displacement 3 meters, we now see that we now have kinetic energy. Okay, so therefore the network acting is going to be, our kinetic energy initial is going to be 0, but just for the standard we are going to assume that our kinetic energy initial is there. So we're going to have we have the same mass, mv final squared minus 1/2 mv initial squared. Okay, so therefore our network is going to equal 1/2 mv final squared minus 1/2 initial velocity is 0. So therefore that's going to equal 1/2 mv final squared minus 0. So let's assume that our final velocity is what? Let's assume that the velocity final is what? Let's say 12 meters per second. So that's the velocity that it took for us to get to that point. So what's going to be the work? What's going to be the net work on this object? Is going to be 1/2. Let's say the mass of this object is, let's say, 50 kilograms. No, that's too much. Let's say 15 times our velocity is what? Our velocity that we gave was 12. Okay, so what we're going to have is 12 squared. So you can plug that into your calculator and then you should get your answer. So that's exactly how you solve this situation.